Hello and welcome! Today, we are going to dive deep into the microscopic world that powers, well, pretty much everything in our modern lives. We're talking about the tiny, tiny tech inside our phones, our computers, our cars. It's everywhere. So, let's get small.
So you've definitely seen this before, right? You're looking at a new phone, and on the box it boasts about a 5-nanometer chip. Sounds super high-tech, but what does that number actually mean? Well, today we're going to crack that code and show you why that tiny little measurement is one of the most important things in all of technology.
All right, to make sense of any of this, we need to start with the basics, and the most basic term you'll hear is something called a technology node.
A technology node is basically just the name for a specific generation of chip making. You can think of it like a model year for a car. And the key thing to remember is the smaller the number, 14 nanometers, 7 nanometer, 3 nanometer, the newer and more advanced the technology is. And crucially, it means the individual transistors on that chip are smaller.
And when we say small, we mean it's kind of hard to even wrap your head around it. A nanometer is 1/1000th of a meter. It's a scale that is just genuinely difficult to picture. Now this is where it gets really wild. Take a single strand of your hair. It's about 80,000 nanometers thick. A modern transistor, that's the tiny little on-off switch that's the foundation of all computing, is down around 5 nanometers. You could fit thousands, literally thousands, of them across the width of a single human hair. It's absolutely mind-blowing.
Okay, so they're ridiculously tiny. We get it. But so what? Why is this multi-trillion-dollar industry obsessed with making them even smaller? Well, it turns out that when it comes to chips, shrinking is basically a superpower. Here's the deal. It all comes down to a golden rule in chip design. Smaller is better. Pretty much always. When you shrink the transistors, you can pack way more of them onto a single chip. And that leads to a whole cascade of good things. Faster speeds, less power being used, and less wasted heat. It's the hat trick of performance and efficiency.
And this right here shows you exactly what I'm talking about. In the same exact physical space where you used to only fit a few big, clunky transistors, now you can cram in tons of tiny little ones. More transistors just flat out means more computing power.
And the reason they're faster is just simple physics. When everything's smaller, the little electrical signals don't have as far to travel to get from one transistor to the next. A shorter commute for those signals means faster calculations, and that translates directly into a snappier phone or computer for you. And here's the magic trick for every portable gadget we own. Smaller transistors need less juice to flip on and off. Less voltage means less power gets pulled from your battery for every single thought your device has. This is exactly why your new phone can have a processor that's faster than a supercomputer from a few years ago and still last all day.
You know, this non-stop push to shrink everything down has been the engine of our digital world for over 50 years. And it's all been guided by one very famous observation.
Way back in 1965, a guy named Gordon Moore, you might have heard of him, he co-founded Intel. He predicted that the number of transistors we could squeeze onto a chip would pretty much double every 2 years. That became known as Moore's Law, and for half a century, it's been the roadmap for the entire industry. And what a road it's been. I mean, just look at this timeline. We went from 180 nanometer chips down to 90, then to a modern workhorse like 14 nanometers, and now the cutting-edge stuff in our pockets is at 7, 5, or even 3 nanometers. The pace of that progress is just staggering.
But, as you can probably imagine, shrinking things down to the size of just a few atoms is not easy. You start running into some seriously weird and incredibly difficult problems with physics and engineering.
Yeah, once you get this small, you hit some major roadblocks. Electricity starts to misbehave, causing something called leakage. Heat becomes a massive problem that you have to manage. You even start to see weird quantum effects, where electrons stop acting like predictable little balls and start behaving in strange ways. And, on top of all that, the cost of just building the factories to make these things has gone through the roof.
So let's talk about that leakage. A transistor is a switch, right? It's supposed to be either on or off. But when the parts are just a few atoms thick, electrons can literally just tunnel right through the barriers that are supposed to stop them. It's like a leaky faucet for electricity. It wastes power and creates a ton of heat, which is the #1 enemy of performance.
So, how did the engineers get around this impossible problem? They did something absolutely brilliant. They went 3D. They invented something called the FinFET transistor. Instead of a flat 2D gate, they built a 3D structure that sticks up like a fin, and the gate wraps around it. This gives them way more control over the flow of electricity, and it dramatically cuts down on that leaking.
Of course, to actually build these tiny, complex 3D patterns, you need a very special kind of tool. That tool is called EUV, or Extreme Ultraviolet Lithography. It uses this incredibly high-energy, short-wavelength light to basically etch the designs onto the silicon with a precision that was just unimaginable before.
And what does a factory or a fab full of these incredible machines actually cost to build? The price tag is almost as crazy as the tech itself. We are talking about $20 billion, with a B. This isn't just advanced manufacturing. It's one of the most expensive and complex things humanity has ever built.
So, after all that mind-bending physics and engineering, let's bring it right back down to Earth. Why should you care about any of this? Because it's literally what makes the device in your pocket work.
And this slide just sums it all up perfectly. That all-day battery life you count on? That's because smaller transistors are super power efficient. The fact that you can run incredible games and apps without a hiccup? That's the raw processing power from having billions of transistors. And your phone not getting crazy hot in your hand? Yep, that's higher efficiency at work, which means less waste heat.
So if you forget everything else from today, just remember this one simple thing. When you see a company announce a new 5-nanometer or 3-nanometer chip, all you have to do is translate that in your head to smaller transistors packed more densely. That's it. That's the secret sauce that has been driving the digital revolution for the last 50 years.
Which of course brings us to the final fascinating question. For decades, we've just followed Moore's law, making things smaller and smaller. But now we're building transistors that are just a handful of atoms across. We are getting very, very close to a fundamental physical limit. So what happens next? How do we keep making our technology better when we literally can't make it any smaller? Well, that is the billion-dollar question that the entire industry is trying to answer right now.